Heavy objects naturally fell toward the center of the Earth, because that was the center of the universe. If the Earth really is spinning and hurtling through space, why doesn't everything fly off? And if the Earth really is spinning, why should an object dropped from a tower land directly below? Why doesn't it land in the next city-state or at least some distance away? 300 years ago, those were logical, intelligent questions. And Galileo Galilei set out to find the answers. A generation later, René Descartes straightened everything out, giving the law of inertia its final shape. Objects in motion don't tend by themselves to come to rest. They tend to continue as they are until something interferes. That fact's easier to see now than it was in Galileo's day. Today, few would disagree that the planet Earth hurtles around the sun. A sun that moves around one corner of a galaxy that moves alone in a cluster of galaxies, all streaking through the unimaginable vastness of the universe. How does the idea of rest fit into this grand scheme of things? It doesn't. Nothing in the universe comes to rest. Instead, anything and everything will continue to move as it is in a straight line at a constant speed until something interferes with it. That's the principle of inertia. And it's both as simple and as profound as any idea that's ever been pondered. Obviously, objects can seem to be at rest, but that's only because they're in the same state of motion as the viewer. Whether an object is at rest or in motion depends completely on viewpoint, on whether the observer's moving right along at the same speed. Absolute rest does not exist. Absolute motion does not exist. Even hurtling through space at an incredible speed, relative to the moon or the sun or the center of the galaxy, the natural tendency of any object is to retain whatever motion it has. In Galileo's day, that was a very difficult concept to accept. But to the modern observer, a vehicle in motion needs no explanation. This coasting object will keep moving until the brakes, or something else, brings it to a state of rest. But what about an object that's not just moving horizontally along with the surface of the Earth? What about a projectile launched into the air? Or a ball dropped from a tower? Shouldn't the spinning Earth leave the falling ball behind? Galileo said it shouldn't. He said the ball should continue to move horizontally with the Earth, even as it falls vertically toward its surface. In the Renaissance, this concept was as hard to grasp as quicksilver. So Galileo offered his contemporaries an analogy. He asked people to picture a ball falling from the mast of a moving ship. To a sailor on the deck, the mast is standing still. He wouldn't be surprised to see the ball fall straight down onto the deck at the foot of the mast. But anyone on shore would see the ship and, of course, the mast in motion. An Aristotelian observer would have no doubt at all about what should happen. The ball should fall directly toward the center of the Earth while the ship sails out from under it. That sailor on deck would see the ball hurtle toward the rear of the ship rather than fall to the foot of the mast. Though the experiment was probably never performed during Galileo's life, the results are precisely what he predicted. The ball falls straight down along the mast. The ball falls along the mast because both objects, ball and sailboat, share the same initial motion. If they don't share the same initial motion, then the result is just as the Aristotelians would have expected. But when dropped from the moving mast, the ball falls vertically while moving horizontally with the boat. Together, these motions form a curved path, a parabola. A ball dropped anywhere on the surface of the spinning Earth behaves the same. Here, sharing the horizontal motion of the planet, it falls straight downward and lands at the base of the tower. In these terms, Galileo saw and proved something new under the sun. In 1616, Galileo was summoned to Rome. He was told to neither hold nor defend this idea of the Earth moving around a stationary sun. Knowing that the Church officially objected to the Copernican system, he waited for the right moment to convince them of the error of their Aristotelian ways. In 1623, Galileo thought that the moment had arrived. His friend and protector, the brilliant Cardinal Maffeo Barberini, became Pope Urban VIII. To enhance his case, Galileo wrote a book, a dialogue in which characters debated the Aristotelian and Copernican systems. However, as any reader could easily gather, the Copernican arguments were much more solid. And perhaps worst of all, since those arguments were in fact written in Italian rather than Latin, common Italians could readily understand them. And as far as the Church was concerned, Galileo made a few more errors of judgment. His fictional defender of Aristotle, who spouted the same arguments the Pope had been making, happened to be named Simplicio, the simpleton. And perhaps most damning of all, Galileo's new book challenged the Church at the very time when it was being challenged from all sides. Galileo was put on trial in 1634. His fame and prestige made it unthinkable to go further than the mere threat of torture. But to Galileo, who knew very well how machines worked, that was enough. He publicly recanted the Copernican system of planetary motion. Ironically, in the future, no serious scientist would deny Galileo's evidence. The principle of inertia, conceived by Galileo and refined by Descartes, became Isaac Newton's first law of mechanics. As far as the Church was concerned, Galileo's name would eventually be vindicated, but it would take a very long time. As recently as 1983, the Galileo controversy was still unresolved. In that year, Pope John Paul II asked that the dispute between Galileo and the Church finally be put to rest. He said, "We cast our minds back to an age when there had developed between science and faith grave incomprehension, the result of misunderstandings or errors, which only humble and patient re-examination succeeded in gradually dispelling. The Church herself learns by experience and reflection, and she now understands better the meaning that must be given to freedom of research." But at the time, even for a famous scientist with an unpardonable ego, public humiliation was not considered punishment enough. Found guilty, in spite of his famous retraction, Galileo spent the remaining 8 years of his life under house arrest at his estate near Florence. According to legend, as Galileo headed into the exile of house arrest, he said, "Eppure si muove." Nonetheless, the earth moves.
Galileo made his real reputation by means of his great discoveries with the telescope. Before that, he had been known only to a handful of experts, but afterwards, he was famous throughout Europe.